This is part 2 for identifying transformations from equations. So number 4, without graphing, identify the vertex, axis of symmetry, and transformations from the parent function, f of x equals the absolute value of x. So I've written this out before, but I'm going to write this again. We have what's called vertex form. All right, and our vertex form is a times x minus h. Let's use absolute values this time. Plus k, where A is going to determine stretches and compressions and potential reflections. H is our horizontal shifts, so left, right. K is our vertical shift, up, down. We can use HK to find our vertex. It's in that form, HK. And then X equals H is our axis of symmetry. All right, so looking at the equation that they gave us, y equals x plus 3 plus 4, I noticed that a is a 1, that's on the outside, that's not going to matter in this problem. My h value, be careful here, h is always the opposite of what it appears to be, so that plus 3 actually means it's a minus 3, and my k value is exactly as it appears, so that would be a 4. So this plus, oops, didn't mean to do that. This 3 tells us my h value, and this 4 gives you my k value. So they want us to identify the vertex, so let's start with that. My vertex is HK. So that tells me that my vertex is going to be negative 3, 4. My axis of symmetry is x equals h. So for this problem, that's going to be x equals negative 3. And then the transformations from the parent function. So my transformations are my h and my k, my horizontal and vertical shifts. So the x plus 3, again, that's backwards, so that's going to tell me that there is a horizontal shift. And that horizontal shift is going to be left 3 units. And then my vertical shift is exactly as it appears. That plus 4 tells me it's going to go up 4 units. So that 4 tells me I have a vertical shift, and that 3 tells me that there's a horizontal shift. All right, number 5, they want us to sketch the graph of the quadratic function f of x. So let's write this out. X plus 3 squared minus 4. By using translations, vertical or horizontal shifts, and compare the graph to the graph of f of x equals x squared. So here we're looking at shifts. What this is going to tell me, this is very similar. Actually, it's exactly the same as the previous problem. We have the plus 3 and the minus, or we have minus 4 in this time. Right. So this minus 4, that tells me that there is a vertical shift, and that's going to go down 4 units. And then that plus 3 tells me that there's going to be a horizontal shift, and that is going to be the opposite of what it appears to be, so this is going to go left 4 units. Oh, sorry, 3 units. Left 3 units. All right, it doesn't ask me for my vertex, but the vertex is always helpful. So my vertex for this problem is going to be, remember, it is HK. So that's going to be negative 3, negative 4. So I'm going to plot that. Negative 3, negative 4 is going to be right here. And that makes sense from my shift standpoint, my translations. It went left from the origin and then down 4 places. So we do need to create a chart that we want to use. My x values, my middle one, again, my recommendation is always to use the vertex as your mid number or mid coordinate point, and then work 2 numbers that are smaller that's not smaller. And two numbers directly that are larger. What that's going to do is that's going to give you two numbers to the left of your vertex and two numbers to the right of your vertex. So you'll be able to see where the graph changes from increasing to decreasing or decreasing to increasing. So we need to take these numbers and plug them in. If I take -5, we're doing a lot of highlighting here. I'm trying not to use the same colors. So we're going to take these 5 numbers and we're going to plug them in as our x values and then determine what our y value would be. So -5 plugged in there would be -2 squared is 4. 4 minus 4 is going to be 0. -4 plus 3 is -1. Squared is 1. Minus 4 would be -3. -2 plus 3 is 1. 1 squared is 1. And then 1 minus 4 is -3. And then finally, -1 plus 3 is 2. 2 squared is 4. 4 minus 4 is 0. As I've mentioned before, these numbers and these should match up if we have put our vertex as our middle number, which we did. All right, so let's plot these points. -5, 0. -4, -3. -3, -4 we already have. -2, -3. Again, it's nice to see that we're starting to show a reflection in a curve there. And then -1, 0, which should be the mirror of that -5, 0 point. We're going to draw ourselves a little sketch of our parabola. And we're done. All right, so if we were to compare this to the original, the parent function of x squared, that's going to be somewhere in here. Oops. That would have been somewhere in here. So it does shift left and down. So it works out. All right, number 6, they're asking us to do the exact same sequence, just with a different problem. So I'm going to try and keep those together. Actually, so we have f of x equals x minus 2 squared plus 4. Going through my terms here, this minus 2 is going to be my horizontal shift. So that tells me I'm going to go, again, the opposite of what it appears. So this is going to go right 2 units. The plus 4 tells me that there is a vertical shift. And that's pretty direct. That's going to go up 4 units. So like I've mentioned before, I like to write my vertex. That's going to help me graph it. HK. So that's going to be 2, 4. So that tells me my horizontal shift. That plus 4 is my vertical shift. And then let's label my vertex as 2, 4. So 2, 4, I'm going to graph that as such. And now I'm going to fill my chart out so I can get the rest of my points. I'll reiterate it. I'm going to repeat it a bunch of times. Use your vertex as your middle point. And then pick numbers that are just slightly smaller and just slightly larger. All right, so I'm going 1 above, 2 above, 1 below, 2 below. You'll then take those numbers, which we did in the previous problem, these ones here, plug them in as your x values to find your new y values. So 0 minus 2 would be -2. Squared would be 4. 4 plus 4 will be 8. 1 minus 2 is -1. -1 squared is 1 plus 4 would be 5. We already have our 2, 4. 3 minus 2 is 1. Squared is 1 plus 4 would be 5. 4 minus 2 is 2. 2 squared 4 plus 4 is 8. So once again, make sure that these match up. That will only work if you follow my rule for picking my x values. Let's plot these points. 0, 8, 1, 5, 2, 4 is already there. 3, 5, again, we're starting to see that reflection. We found that vertex, and 4, 8. I missed there a little bit, but you get the idea. If they want you to compare it to the original, remember your original is going to be somewhere, that was the terrible color to use. Your original would have been somewhere around here. And if you have that original and you shifted it right 2 units and then up 4, you'd wind up at our new function. All right. So you should be able to do that without too much of an issue. You'll definitely get used to these vertical and horizontal shifts. And I can't stress it enough, use your vertex as that middle point. If you use that, it's going to help you a lot. It'll guarantee that you have the vertex, but it also helps you pick the other two numbers above and below.